What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light-years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff, but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted two supermassive black holes, feasting on the cosmic material of two merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch two merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shockwaves travel far into dark space, and the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light-years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see It's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there.
You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space, and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star. NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves, so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center, a triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks, and every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time, NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to Mission Control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative than we think.
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yup. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that Interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-great-grandchildren will be around to see. Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, a giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops!
Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if 2 or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila! A stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our sun? And in that case, what will happen to us? Well, actually, the likelihood of the sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our sun, and even this one is about 1,600 light-years away from us, which is a quadrillion miles. So, it's safe to say that our sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans, the Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All the planets would be destroyed. Now, the Sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the Sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the Sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the Sun. Let's hope by that time, we will already be living on other distant planets. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would never have found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there was no end. It sounded pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Pienzas and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Pienzas and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to negative 455 degrees Fahrenheit with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So what is this cold spot, and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision. For quantum mechanics, such crazy theories are pretty common, but for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analysis. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory. It could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it.
To see one of the most significant astronomical events of all time, we go to South America. In the Atacama Desert, Chile, we find the most advanced technology for space observation. Here, the Royal Astronomical Community members watched for 6 months as a black hole simply absorbed a massive star. By the way, these are the same scientists who proved that in the center of our Milky Way galaxy is a supermassive black hole, and even took a photo of it. For the first time in history, this incredible event happened very close to Earth. Well, the distance of 215 million light-years is considered quite close in astronomy terms anyway. Light from this event reached our planet in September of 2019, and even the most experienced scientists dropped their jaws in surprise. Imagine a star the size of our Sun, about 860,000 miles wide. Such stars have enough weight to create a strong gravitational field holding many planets in their orbit. And now, let's place a giant black hole next to it. The hole is absolutely black, shaped like a disk, and weighs 1 billion times more than this star. The force of its gravitational field is incredible. Nothing can leave its gravity force. Objects that can move at the speed of light will still fall into this black abyss. Even light itself cannot escape its boundaries. As soon as a star enters the gravitational field of a black hole, it has no chance. At first, it tries to resist the pull of the black hole. Still, the star's outer layers begin to stretch toward the black hole, just like spaghetti. This is due to a powerful force of attraction. If you had the opportunity to extend your hand toward the black hole, you would see your fingers begin to stretch and elongate. This is because the force of attraction increases with every inch. Therefore, it acts stronger on your fingers than on your arm. That's why this process of pulling objects into a black hole is called spaghettification. The first thing to be sucked into the black hole is the star's crown. This is the outer shell of the star, which consists of hot plasma. You may notice how the star begins to shrink in size. This is because that plasma makes up most of the visible sun. When this hot plasma spaghetti reaches the black hole, it may appear to remain on the disk's edge and continue to orbit the black hole. But in fact, there is no turning back anymore. The star's particles have already hit the event horizon of the dark abyss. The gravitational field of a black hole bends light around its edges, so the event horizon looks a bit like a croissant for the observer. Boy, lots of food metaphors here. I'm getting hungry. You may also notice a kind of chaos in this ring, as if some light particles are moving in one direction and others in another. This happens because of a mirror effect. But you can be sure that whatever reaches the event horizon will, sooner or later, be pulled into the singularity, or the black pearl of the black hole. Another illusion you spot is the star particles in the event horizon moving slower. The truth is that supermassive objects like a black hole curve space-time around them, and the more massive the object, the slower time flows near it. If you hang one watch beside a black hole and another on a wall in your bedroom, you will see that the second hand in the first watch barely moves, while a whole day passes on Earth. As observers, it seems to us that the particles of light have slowed their movement. But in fact, they may have already been absorbed by the black hole ages ago. Now, massive streams of red-hot plasma splash into space, just like spaghetti sauce. When a black hole has absorbed star material, it emits powerful rays of energy at a rate of about 6,200 miles per second. This release of energy is accompanied by an intense flash. It's thanks to this flash that scientists can even detect this process in the first place. This phenomenon can be observed when a supernova explodes. When nothing remains of the star's body, we can still see stardust and other particles in the black hole's event horizon. Kinda like the Parmesan cheese sprinkled on the spaghetti. Hey, stop me if I'm taking this too far. When the process of spaghettification is completed, about half of the star's weight has been thrown into outer space as dust and glowing particles. The other half was entirely absorbed by the black hole. The scientists observed this process for almost 6 months. But what would be more interesting is to dive into a black hole yourself. Well, we can't do that yet, but we can simulate this process. Here's a little drone, our metal friend, kinda like a meatball. No, I haven't had lunch yet. Right now, it's at a safe distance from the black hole, the length of about 3 widths of the event horizon. Objects at this distance can orbit the black hole safely. A little closer, and it'll be swallowed up by a dark infinity. So, our destroyed star could have safely existed at this distance. Moreover, planets can live at this distance. And if there is a suitable source of light and heat somewhere nearby, life can exist on these planets too. But our goal is the singularity, and we guide the the drone, closer to the event horizon. After a few minutes, the force of attraction begins to strengthen, and the drone starts to stretch like spaghetti. When it begins spinning around the black disk, it means it has reached the event horizon and has started its descent into the black abyss. Now let's look at everything from the drone's perspective. All the light from the stars that it sees becomes blue. This is called gravitational blue shift. As it falls into the black hole, its gravitational field pulls the photons of light down, giving them energy. Their wavelengths grow shorter, so the red photons change into blue. The drone continues to fall and is already completely hidden from our eyes. And all that the robot sees is a bright, thin blue beam. Now it's in complete darkness. There's absolutely nothing here, not even time. Here, time goes so slowly that our entire solar system could grow old and cease to exist during a minute spent in a black hole. But our drone will live until its battery is empty. Hey, the drone sees a small bundle of light again, and it's getting closer and more prominent. Now the drone will experience the same fall, only in reverse. Once the drone leaves the singularity, the heart of the black hole, it will be on the event horizon once again. The light from the stars gradually changes from blue to red. Then the drone is thrown into outer space, perhaps in some faraway galaxy. Well, returning from a black hole is just a theory. Some people think that black holes are a kind of wormhole that can lead us to distant places in space. But so far, these theories are considered fiction. Black holes are quite challenging to detect. The problem is they are, well, black, just like space. They don't emit light like stars, so they can only be detected by gravity anomalies. Despite this, scientists believe there are a vast numbers of black holes in our universe. They're born when a massive star collapses under its own weight, and given the infinite number of stars in the universe, black holes are probably a common phenomenon. Scientists believe black holes have their own lifetimes. This is because of Hawking radiation. A black hole loses mass, and so, to continue existing, it has to absorb massive objects, like the star we just watched. But if the black hole lives in deep space, it has less to absorb, and will most likely begin to shrink until it just disappears. Like this plate of spaghetti. You know, rotation is a funny thing. Not haha funny, but kinda strange. Not only can't you feel it, everything does it. From galaxies to atoms, the universe is taking us for a spin. Strangely, it was more difficult to prove that the Earth is rotating than it was to prove that the Earth is revolving around the Sun. Way back in 1610, Galileo, the father of experimental science, provided the first proof that Earth and all the other planets revolve around the Sun. Galileo showed in his telescope that Venus was going through phases like the Moon. The only conclusion possible was that Venus was revolving around the Sun. Case closed. Planets revolve. But it wasn't until 241 years later, March 31, 1851 to be exact, that Leon Foucault proved that Earth was rotating. Foucault installed a giant pendulum from the 220-foot-high ceiling of the Pantheon in Paris. That's a lot of peace. An assembly of scientists and journalists watched as the floor turned beneath the giant pendulum. "The Earth turns," they shouted, mostly in French. Another strange thing about rotation is that although the Earth is rotating at a constant speed, the surface of the Earth is moving at all different speeds at all different latitudes. The same is true for every planet and star. At the equator, the surface of the Earth is moving the fastest at 1,037 miles per hour. That's much faster than the speed of sound, which is a mere 761 miles per hour. Halfway from the equator to the North or South Pole at 45 degrees latitude, the Earth is rotating at 733 miles per hour. Standing at the North or South Pole, it would take you 24 hours just to turn around one time, and that's both boring and cold. One result of these differential rotational speeds of Earth is that it creates belts and bands not only in the atmosphere, but also on the surface of the Earth. Jupiter, of course, is famous for the belts and bands in its clouds caused by the giant planet's rapid rotation of about 28,000 miles per hour. The belts and bands on Earth's surface are somewhat overlooked, but we've got them too. We have white ice at the North and South Poles, and between the two poles, there are alternating belts and bands of dry sandy desert and moist green vegetation. This essential geography can be seen most clearly when we view the Earth rotating in space. Space agencies use the differential rotation of the Earth to their advantage. They launch their rockets as close to the equator as possible. NASA uses Cape Canaveral near the southern tip of Florida. And the ESA, the European Space Agency, uses the Guiana Space Center in French Guiana, South America, almost exactly at the equator. Because the land under a rocket near the equator is rotating at a greater speed, it gives the rocket a boost into space that launch sites near the poles cannot provide. You always want to save fuel, you know. Speaking of Jupiter, as I did about 3 paragraphs ago, the axis of rotation of the big planet is even less inclined than that of the Sun. The Sun is tilted at an angle of around 6 degrees, while Jupiter is only tilted 3 degrees. Jupiter stands almost perfectly upright, which combined with the great speed at which Jupiter is rotating, its entire day is less than 10 hours, it turns Jupiter into a giant gyroscope. Jupiter's gyroscopic stability, combined with its massive gravity, gives stability to the whole solar system. Jupiter prevents chaos factors from disrupting the orbits of the other planets. In other words, without Jupiter rotating like a stable gyroscope, the solar system could never have stayed intact for the billions of years that it has. Exoplanet solar systems are showing signs of chaos in their orbits. They could use a gyroscope like Jupiter to hold them together. Rotation is the real hero here. As for the Sun, its differential rotation has a big effect on its sunspot activity. Sunspots are spots or patches that sometimes appear on the Sun's surface, usually at mid-latitudes in both the northern and southern hemispheres of the Sun. As sunspot activity increases on the Sun, sunspots begin to move closer to the equator. Few sunspots are ever seen near the poles. With differential rotation, the gases at the equator of the Sun are moving faster than the gases at the Sun's poles. This differential motion of the gases twists the magnetic field lines in the Sun, causing them to snap. Sunspots are magnetic eruptions rising through the surface of the Sun, hurling electrified gases far into space and emitting intense ultraviolet radiation, often in the direction of the Earth. Uh-oh. Well, have no fear, Earth's differential rotation protects us. Not only does our Earth rotate differentially on its surface, but also down into its center. Studies of seismic readings of shock waves from earthquakes indicate the metallic core of the Earth is rotating slightly faster than the surface of our planet. Scientists think that the differential rotation of Earth's magnetic core within the slower rotating metallic liquid creates the magnetosphere arising from Earth's poles and extending far out into space. This magnetosphere keeps Earth safe from electrified gases from the Sun. Hurrah for rotation! Far out! Now, the 9.0 megaquake in 2011 off the coast of Japan rearranged the mass of Earth's crust and caused the rotation of Earth to speed up. The day got shorter. Not much shorter, 1.6 millionths of a second, but we are accustomed to seeing the Earth's rotation slowing down. The Earth rotating through the tidal action of the Moon's gravitational effect on the oceans drains kinetic energy from the Earth's rotation, causing the planet to slow down. Each day is becoming longer, about 0.02 of a second longer. Well, I need to adjust my watch. Leap years, we all know, are when we add a day to the calendar every 4 years, on February 29th, to straighten up Earth's yearly rotation around the Sun, taking 365 1/4 days. But leap seconds are added to the clocks every so often to synchronize our clocks with the slowing rotation of the Earth, and allow the Earth to catch up with our clocks, as if the Earth is concerned about our timepieces. 27 leap seconds have been added since 1972. The last leap second was added on December 31, 2016, and made the clocks read 6:59:60 p.m. Yeah, I didn't notice either. But the Sun's rotation has unexpectedly been speeding up recently. Usually it takes 86,400 seconds for the Earth to rotate, as measured by an array of atomic clocks in different locations on Earth and coordinated by a special service in Paris. Yes, they pay people for that. July 19, 2020 was the shortest day ever recorded, a whopping 1.46 milliseconds less than the usual 86,400. Gadzooks! If this keeps up for another 5 years, they may have to add a negative leap second to synchronize our clocks to Earth's increasing rotation. Computers and satellites won't like to see their clocks read January 1st at 0 o'clock, and they say time can't go backward. At least the Earth hasn't started rotating backward or stopped rotating altogether. That would be catastrophic. Everything would crash forward at whatever differential speed it was rotating on Earth. Yet that appears to be what happened to the planet closest to Earth, Venus. Venus rotates very slowly backward, in retrograde, and that is very unusual. How so, you ask? Well, there are several theories to why Venus rotates in retrograde motion, while all the other planets rotate in prograde or forward motion. Liquids inside a rotating sphere, like a planet, have a lot of inertia. That's why when you take an egg from the fridge, for example, and try to spin it, it won't spin. The liquid inside is just sitting there. Its inertia is resisting your attempt to spin it. However, if finally, after many turns, you manage to get the raw egg to rotate, it's hard to get it to stop spinning. If you do pick it up and put it back down, the egg will start rotating again, because the inertia of the liquid inside it is still going forward. You only stop the shell from spinning. Something like this may have happened to Venus. Wait a minute. Venus? Backspin? Tennis? I think there's a connection here, somewhere. We know that on Venus, the planet, one day is longer than 1 year. It takes longer for Venus to slowly rotate around backward one time than it takes Venus to orbit the Sun once. But Venus is slowing down dramatically, and by 6.5 minutes in the last 25 years. If there still is liquid inside Venus and the movement continues, we might see Venus completely stop spinning backward and start rotating forward again. Come on, Venus, let's get with the crowd. This business of retrograde and prograde rotation has got quite a bit of mystery to it. It seems that everything tends to rotate in prograde motion. If you shape your right hand like a ball and stick your thumb up to indicate north, then curl your wrist towards you, that's prograde motion. Your fingers on the left side of your hand are moving towards you. Black holes, solar systems, galaxies, atoms, stars, etc. all seem to rotate prograde, depending on which angle you view them from. Experiments at the Large Hadron Collider indicate that subatomic particles spin toward the left, prograde. It's starting to look as if we may be in a left-handed universe. Then why is it so hard to find a left-handed manual can opener or measuring tape? I don't know. It's a mystery.
You know how galaxies have supermassive black holes in their centers? In most cases, we don't have to be afraid they'll come after us. They stay at the same spot for eternity, or at least until they start to evaporate and give the energy they have stolen back to the universe. But there's always that one rebel that spoils the statistics, like this invisible beast that ran away, moving farther and farther from its home galaxy. It escaped with style though, leaving a shiny trail of stars behind it, like a wake behind a ship. And it's moving really fast. If it was somewhere in our solar system, the moving black holes could cross the distance between our home planet and the moon in a mere 14 minutes. A regular spacecraft needs 3 days to do that. The unusual Space Wanderer weighs as much as 20 million suns and has left a trail of newborn stars 200,000 light-years long, which is twice the diameter of our galaxy. No one has definitely seen anything like that before. There are a few ways a supermassive black hole can run away from its home. One of them is when two galaxies come together in a big collision. As they hit each other, you get a pair of supermassive black holes that start dancing in circles around each other. If there's one more black hole that decides to join the party, it can give a big push to one of the dancers and kind of catapult it far away from the center of the galaxy. Another way is when the two dancers finally catch up with each other, align their moves, and become so compatible they merge at one point. This new black hole they create can get a push or a kick, and before it even knows it, it's somewhere far, far away from the safety of its home. This runaway black hole we're talking about is probably the result of many collisions of giant black holes. Their home galaxies probably merged around 50 million years ago, which brought these two together. Then, an intruder likely appeared, another galaxy with its very own giant space vacuum, and things quickly became chaotic. As one of those three tried to steal the moment from the other two, it ended up thrown out of the galaxy. The original pair may have stayed there, or maybe the guest took the place of one of them. Don't think it's always that easy to go after the rebel and talk it into going back home. It's generally really hard to detect black holes. Sometimes they give away their current position when they eat large volumes of stuff they find on their way, such as gas and stars. When they're full, they become very bright. But the rest of the time, they just eat a normal amount and hide in the eternal shadows of the cosmos. They leave traces when they come closer to objects in space. We may not be able to see black holes directly, but special telescopes can catch what they do to their environment. For example, we can observe a star that makes circles around something we can't see instead of orbiting its binary companion star as we'd expect. Scientists can measure how fast that star is speeding up and calculate the mass of the object that's pulling on it. And when the mass is so big they can't match it with anything they know about, it means it's probably a black hole. Also, special X-ray telescopes can recognize radiation emitted by a star that has come too close to a black hole, which is now pulling it apart with its strong gravity. Black holes have an accretion disk, which is like a swirling thing that orbits them, like a whirlpool. When stuff from their surrounding falls into this whirlpool, it gets very hot and starts shooting out X-rays. Supermassive black holes have a mass of over 1 million suns, so it's not surprising they shoot out gas particularly far into space, sometimes even millions of light years away. Anyway, our rebellious black hole was hard to spot, considering how it kept moving faster and faster. But unlike others, it's never tried to hide, considering that shiny trail of stars. It doesn't gobble up stars that are ahead of it. Obviously not a fan of Pac-Man. Poor fella doesn't even have time to stop and grab a quick bite. Instead, it's just plowing into gas in front of it, which triggers the formation of new stars along its narrow path. The gas probably cools and forms a trail that's nearly half as bright as the galaxy itself. The black hole sits at the top of the column that stretches all the way back to its parent galaxy. It seems like this runaway wants to mark the way wherever it goes, in case it ever decides to get back home. And over there, at its tip, there's a glowing knot of ionized oxygen. It's probably there because it got shocked and heated from the black hole moving and hitting the gas. Or maybe this could be radiation coming from the accretion disk. This is not the only unusual black hole traveler that decided to take a different path in life. Astronomers have found another wanderer, a black hole, completely on its own for the very first time. Big stars can explode and turn into black holes, but in most cases, these black holes have star companions. When they come in a binary system, they interact with their partner so you can find them easier because of the light around them. That's why finding this solo traveler wasn't easy at all. It just didn't give off any light. But the Hubble Space Telescope did a pretty good job of finding how the gravity of this sneaky black hole bent light around it, similar to how a magnifying glass does. It's cool that we found something like this because it tells us there could be more of these loners that prefer traveling alone, hiding in the dark. These black holes sound scary, but the comforting thought is they're very far away. Take this lonely wanderer as an example. It's 5,150 light-years away from our home planet. But in 2020, scientists thought that they had found the closest black hole to Earth, only 1,000 light-years away from us. It was really big news until they realized they had actually fallen for an optical illusion. They thought there were 3 giant things over there. A big star making a circle around a black hole every 40 days, with one more star whose orbit went way farther. But it seems it was just a system of 2 stars orbiting each other closer than expected. But we've still got something cool to observe, because they're so close that one of the stars is pulling the atmosphere off the other. Yup, stars have their own vampires too. This vampire star is way bigger and spins faster than the other one. This results in an illusion that they're orbiting each other farther apart than in reality. Still, if I had to choose between these vampire stars and J114 in our galaxy, I'd definitely choose them. The latter one is a terrifyingly big black hole about 3 billion times heavier than our Sun. Our planet is not even a crumb in its morning bowl of cereal since it eats chunks of matter as big as the whole Earth every second. We're talking about the brightest and fastest growing black hole we've seen in the last 9 billion years. What's also fascinating is that this black hole devours matter so quickly that its boundary, which we call the event horizon, is really wide. You could easily fit all the planets of our solar system inside. The cool thing is also that its event horizon is so bright even amateur astronomers with good telescopes can see it if they look for it in the right part of the sky.
What the? Look! Do you see this? Part of the sun has broken off, and it's now churning above the star's surface, having formed a giant vortex. What's going on there? Well, let's admit it. We still know very little about the sun, however crucial this star is for our well-being. But in the case of the broken sun, scientists can probably explain what happened. Some of the star's plasma likely erupted from the sun's surface and broke away, creating something resembling a crown-like vortex over the solar North Pole. And still, this is just a theory. Astronomers need to conduct further analysis to figure out if this is what really happened. At the moment, they're a bit baffled, since this phenomenon is nothing like anything they've seen before. But the footage we've got is undeniably impressive. What is more alarming, though, is that the behavior of our star is currently changing. The sun is ramping up its activity. It's getting rowdier with flares and sunspots. This year, it's flared every day so far. It's also thrown up a few X-class and M-class flares in January of 2023. These flares are the largest and second largest eruptions our star can produce. Even though it sounds kind of alarming, don't worry. The sun has certain activity cycles that repeat every 11 years or so. Some of them are relatively calm, while others are absolutely wild. These cycles happen simultaneously with the fluctuations in the sun's magnetic field. When it gets the weakest at the star's poles, they switch places. This makes the polarity of the magnetic field reverse. This is the very period of time when the sun is the most active. It's known as solar maximum. Right now, we are near this solar maximum. Scientists can figure it out by analyzing unusual solar activity. But since the sun is still pretty much a mystery to us, no one can determine when the polarity reversal is likely to occur. A rough estimation is July of 2025. At the same time, We can't say that the current solar situation is normal. It's true that each sun's cycle is different from others. Some are weaker and some are more powerful. So this one, which started in December of 2019, has already significantly exceeded all scientists' expectations and keeps doing so. Which brings us back to the vortex observed on February 2nd, 2023 that impressed astronomers so much. It started as a solar prominence. This is a bright plasma filament extending away from the surface of the sun. And, let me tell you, solar prominences are an absolutely regular phenomenon. And like the most recent one, they often occur at high altitudes around the sun's crown, which is the outermost layer of the star's atmosphere, also known as the corona. Anyway, prominences like the one in question are called hedgerow prominences because they look like a hedge. But what surprised astronomers happened a bit later. The material of the filament apparently broke away and started circling the pole near where it occurred at 60 degrees latitude and at a speed of about 60 miles per second. And it lasted for about 8 hours. One scientist, who has been observing the sun's cycles for decades, claims that he has never seen vortices like that. Unfortunately, solar poles are very difficult to observe, so it might be a while till we get our answers. For the first time, a spacecraft touched the surface of the sun in 2021. It was NASA's Parker Solar Probe that flew through our star's upper atmosphere. It also took some samples of particles and examined magnetic fields there. It was a real milestone and a giant leap for solar science. Getting their hands on the very stuff the sun is made of will allow researchers to uncover crucial information about our star and its influence on us and the entire solar system. The Parker Solar Probe moved closer to the sun's surface and started making discoveries that other spacecraft were too far away to see. For example, the probe examined the solar wind from within. It's a flow of particles coming from the sun. These particles can influence us here on Earth. Even before coming super close to the star, the Parker probe found out that near the sun, there were loads of magnetic zigzag structures in the solar wind called switchbacks. But at that time, scientists couldn't figure out how they formed and where they appeared. But now, more than 2 years later, we know for sure that switchbacks originate at the solar surface. As you know, the sun doesn't have any solid surface, unlike our planet, but it has a superheated atmosphere, which is made of solar material bound by magnetic forces and gravity. When pressure and rising heat push that material away from the star, it eventually reaches a point where the sun's magnetic field and its gravity can't contain it anymore. This point has its own name, the Alphane critical surface. It marks the edge of the solar atmosphere, and that's also where the solar wind begins. The material that manages to make it past the boundary turns into the solar wind. It drags the sun's magnetic field toward Earth and beyond. But the most important thing is that past the boundary, this wind starts moving so fast that its waves can't return back to the sun, which literally means severing all connections with the star. During its flyby, the Parker probe passed inside and out of the sun's corona several times, which proved that the Alphane critical surface wasn't shaped like a smooth sphere. It has valleys and spikes, and its surface is kinda wrinkled. At one point, the probe even came across a pseudo-streamer. These are massive structures in the sun's corona that rise high above the surface of the star. You can see them from Earth during solar eclipses. And you know what? For the Parker probe, passing through the pseudo-streamer was like flying into the eye of a storm. Inside, everything was much quieter. Particles moved more slowly, and there were fewer switchbacks. It was a huge change from the barrage of particles the probe encountered inside the solar wind. Now, speaking of solar flares, those are pretty dangerous for Earth. The radiation they release can interfere with our radio communication. Such storms affect all electronic systems, from the internet to power grids, and can even destroy satellites. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares that people should be worried about. They cause the strongest and longest-lasting solar storms. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. A powerful solar storm could cost people $1 trillion to $2 trillion. Luckily, if such a powerful solar storm was heading our way, we'd most likely get some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. It would give us some time to prepare, between several hours and a couple of days. And if transformers were taken offline in time, the consequences wouldn't be so dramatic.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
and will start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X-solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to to Proxima Centauri b. That's a planet near the closest star system to our Sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our Sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the Sun? Did the black hole swallow it? The Sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the Sun. Maybe our Sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking, and will disappear at some moment. Our Sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either, so even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the Sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our Sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our Sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the Sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the Sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the Sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the Sun, at which liquid water could exist on the surface of a planet. Now that the Sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the Sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system, until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5-degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life, so the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom! What would happen to us and our planet if it became as big as the sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the sun, about 865,000 miles. Compared to our Earth, the sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the sun. Scenario 1. The Earth becomes as large as the sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have two suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having two centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining ex-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our two-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the Sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.
Is it possible to put out the Sun? For example, what would happen if we poured all of the Earth's oceans on it, or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works, but none of us has ever doubted the existence of one thing: the Sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the Sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the Sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the Sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the Sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the Sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the Sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The Sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the Sun. People often underestimate how much bigger the Sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the Sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the Sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the Sun again. Wow, just look at the steam! But the Sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the Sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the Sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the Sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the Sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The Sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the Sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the Sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the Sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the Sun heavier. Now, gravity says, thank you for your help. And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the Sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the Sun will sooner or later collapse in on itself. it will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have two options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes?
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the Sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are two stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These two aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny.
So, what's going on with all the news about the Sun? Some say that the Sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the Sun is likely to get. The Sun usually goes through an active-calm active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the Sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the Sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the Sun gives off. Thankfully, the amount of visible light the Sun gives off doesn't change very much. That would be a serious problem. If the Sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the Sun is. The more sunspots that are visible, the more active the Sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the Sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The Sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the Sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the north and south pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this